Okay, today we're going to start on Chapter 15, Electric Forces and Fields. I think we all understand the importance of electricity in our everyday life. I mean, we couldn't have our cell phones, we couldn't have hot water, we couldn't have, electric stoves. It's just, it's everywhere. And so the electricity is really important to us. And let's this is to understand the basics. So so you try running a comb through your hair or rub a balloon on your hair. It can stick to the wall. If you run the comb through your hair and hold it above some bits of paper, you'll find that the comb attracts bits of paper, and sometimes the paper is actually suspended from the comb. Imagine a force strong enough to defy the gravitational pull of the entire Earth. The same effect occurs with other rubber materials, glass and hard rubber. You can try the simple experiment of rubbing an inflated balloon against wool or across your hair, and on a dry day, the rubber balloon will stick to the wall, sometimes for hours, a long time. These materials have become electrically charged. The photo in the PowerPoint shows another example of this, where here the little girl's hair is electrically charged from rubbing against a plastic chair. You can give your body an electric charge by rubbing your shoes on a wool rug or by sliding across a car seat. Then if you touch another person, you both might feel a shock. These experiments work best on a dry day because moisture helps the charges to leak away. Sometimes you're at HEB, you're pushing a shopping cart, and you touch, if it has a plastic handle, you touch the metal part of the shopping cart, you can get a shock. At least I do. All right. Experiments show that there are two kinds of electric charge, which Benjamin Franklin named positive and negative. The figure shows the interaction of the two charges. First, a hard rubber or plastic rod is rubbed with fur. Then it is suspended by a piece of string. When a glass rod that has been rubbed with silk is brought near the rubber rod is attracted toward the glass rod, as shown in the figure on the left. If two charged rubber or glass rods are brought near each other, as the figure on the right, the force between them is repulsive. We can explain these observations if we assume the rubber and glass rods have acquired different kinds of excess charge. We use the convention suggested by Franklin, where the excess electric charge on the glass rod is called positive, and that on the rubber rod is called negative. On the basis of observations like these, we can conclude that like charges repel one another and unlike charges attract one another. Objects usually contain equal amounts of positive and negative charge. Electric forces between objects arise when those objects have negative or positive charges. Nature's carriers of positive charge are protons, which, as you know, are located in the nuclei of atoms along with the neutrons. The nucleus is about 10 to the minus 15 meters in radius and is surrounded by a cloud of negatively charged electrons with a radius about 10,000 times larger. An electron has the same magnitude charge as a proton, but the opposite sign. In a gram of matter, there are approximately 10 to the 23 positively charged protons and just as many negatively charged electrons, so the net charge is 0. The nucleus of an atom isn't free to move around, so protons never move from one material to another. Electrons are much lighter than protons and are easier to accelerate, and they occupy the outer regions of the atom. For these reasons, objects become charged by gaining or losing electrons. Charge transfers easily from one type of material to another. Rubbing the two materials increases the area of contact, which makes the transfer process easier. One characteristic of charge is that electric charge is always conserved. Charge isn't created when two neutral objects are rubbed together. The objects become charged because negative charge is transferred from one object to the other. One object gains a negative charge, while the other loses an equal amount of negative charge, and so it is left with a net positive charge. When a glass rod is rubbed with silk, as in the figure, electrons are transferred from the rod to the silk. So that means the glass rod carries a net positive charge. The silk is net negative charge. In the same way, when rubber is rubbed with fur, electrons are transferred from the fur to the rubber. Okay, in 1905, the photo is a photo of Robert Millikan. In 1909, Robert Millikan, who lived from 1886 to 1953, discovered that if an object is charged, its charge is always a multiple of a fundamental unit of charge, E. In modern times, a charge is said to be quantized, meaning that charge occurs in discrete chunks that can't be divided anymore. An object may have a charge of plus or minus E, plus or minus 2E, plus or minus 3E, and so on, but never a fractional charge. A neutral atom, an atom with no net charge, contains as many protons as electrons. The value of E is given as 1.60219 times 10 to the minus 19 coulombs. And that's this section. We'll go on to the next section of insulators and conductors on the next video.